Passive design strategies are architectural approaches that utilize natural elements and local climate conditions to maintain a comfortable indoor environment in a building. Summer sun path, high and northerly arc. In summer, the sun rises significantly north of east. In summer, high sun from the south, low sun from the east and west, problematic. Winter sun path, low and southerly arc, sunrise. In winter, the sun rises significantly south of east. In winter, low sun from the south and low sun from the southeast and southwest. Less problematic for heat, potentially useful for warmth. North always receives diffuse, indirect light, making it the preferred orientation for large windows and daylighting to avoid heat gain. Imagine this is the top view of a simple house. North side, see the big windows. This is where you want them for lots of light without heat. South side, windows here would have a roof overhang to block the high summer sun. East and west side, see the small windows. These sides get harsh sun. It's best to have fewer smaller windows here, or use vertical shading or trees. Wind. The wind usually blows from the west/southwest. By having windows on the west and north sides, you can get a good cross breeze flowing through the house. By following these simple ideas, your building will stay cooler naturally, and you'll save energy on air conditioning. Wind catchers or bedgears are passive architectural elements that harness natural wind to ventilate and cool buildings. They are typically tall chimney-like structures with openings at the top that capture prevailing winds. The incoming wind creates positive pressure, pushing cooler air down into the building, while simultaneously creating negative pressure that draws warmer, stale air out, either through other openings or a separate part of the wind catcher. This creates a constant airflow, providing natural ventilation and a cooling effect, often enhanced by evaporative cooling if water is incorporated within the tower. In passive design, an insulation double wall functions as a highly effective thermal barrier, significantly reducing heat transfer between the interior and exterior environments. This strategy typically involves creating a cavity between two layers of wall construction, which is then filled with insulating material, like mineral wool, cellulose or foam, or sometimes even left as a sealed air gap. This layered approach minimizes heat gain in hot climates by slowing down the conduction of heat from the outside in, and similarly, it reduces heat loss in cold climates, keeping the interior warm. The double wall system, particularly when combined with airtight construction, creates a super insulated envelope that dramatically improves thermal comfort and lowers energy consumption. Water bodies are a valuable element in passive design strategies, particularly in hot and dry climates. They contribute to cooling through evaporative cooling, where the evaporation of water absorbs heat from the surrounding air, lowering its temperature. This cooled air can then be drawn into the building through natural ventilation, creating a comfortable indoor environment without the need for mechanical air conditioning. Strategically placed ponds, fountains, or even misting systems can significantly enhance a building's thermal performance, reduce energy consumption, and create a more pleasant microclimates. Green roofs contribute significantly to passive design by acting as a natural insulating and cooling layer on a building's top. The vegetation and growing medium on the roof reduce heat transfer into the building through evapotranspiration, where plants release water vapor, absorbing heat from the air and lowering the roof surface temperature. Additionally, the soil and plant layers provide excellent thermal insulation zeeks, preventing heat gain in hot climates and heat loss in cold climates. This combination significantly reduces the need for mechanical heating and cooling, leading to lower energy consumption and improved indoor thermal comfort. Terracotta pot evaporative cooling utilizes the natural porosity of unglazed clay to cool spaces or objects. When water is added to a terracotta pot, it slowly seeps through the tiny pores to the outer surface. As this water evaporates into the drier ambient air, it absorbs latent heat from the surrounding environment, thereby lowering the temperature of the pot itself and the air immediately around it. This passive process, akin to human sweating, creates a localized cooling effect without the need for electricity, making it an energy-efficient and sustainable design strategy, especially effective in hot and dry climates like much of India. Shading and solar control are crucial passive design strategies that prevent unwanted solar heat gain, especially during warmer months, thereby reducing the need for mechanical cooling. This involves carefully designed architectural elements like overhangs, louvers, fins, or even strategic landscaping, like deciduous trees, to block direct sunlight from entering the building's interior. Effective solar control not only minimizes overheating but also helps manage glare, creating a more comfortable and visually appealing indoor environment while significantly lowering energy consumption for air conditioning.